Part of the physics lab I mentioned in the previous video was to experimentally determine the spring constant of the spring. The way we did this was we measured the natural length of the spring with no mass attached, then attached a weight of known mass, and measured the displacement of the mass from its natural length once the spring reached equilibrium. A spring mass system is in equilibrium when the attached mass is at rest and the net force on the mass is zero. We call the position of the mass when the system is in equilibrium the equilibrium position. How does this help us calculate the spring constant? Let's consider the forces involved when the system is in this situation. The spring is stretched by the mass past its natural length, so the restoring force, Fs equals negative Ks, is involved. The mass is hanging vertically, so the force due to gravity, F equals mg, is involved. The mass isn't moving, it's at rest, so there's no motion to oppose, so there's no damping forces. And the mass is just hanging there, so we clearly aren't applying any external forces. So we have only two forces acting, the restoring force and gravity. And since the net force is zero, the magnitudes of the two forces must be equal. So K times S must equal mg. This lets us easily calculate the spring constant as K equals mg over S, where m is the attached mass and S is the stretch past natural length at equilibrium. Let's do an example. A 10 kilogram mass is attached to the end of a hanging spring and allowed to come to rest. The weight causes the spring to stretch 12 centimeters. Find the spring constant in newtons per meter. This is as simple as plugging values into the formula. The units are all in metric, so we'll use G equals 9.8 meters per second squared. Just remember that when we use US units like pounds, we're going to handle things slightly differently. And since we are asked for newtons per meter, we have to change the centimeters into meters. So K is mg over S. M was given as 10 kilograms. We said for G, we're going to use 9.8 meters per second squared. And then our S needs to be changed into meters, with 12 centimeters divided by 100 centimeters per meter is 0.12 meters. And then when we plug that into our calculator, we get that is approximately 817 newtons per meter, because 1 newton is 1 kilogram meter per second squared.